Script. Hey everyone and welcome. Today, we're tackling a neat problem called maximum difference between increasing elements. It sounds a little formal, but the idea is actually pretty straightforward. We'll break it all down, step by step. Script. Alright, so here's the official problem description. But let's put it in simpler terms. We get a list of numbers. Our job is to find two numbers in that list. The first one, let's call its position I, must come before the second one, whose position we'll call j. And there's one more rule. The number at position j has to be strictly greater than the number at position I. Our goal is to find the pair that follows these rules and gives us the biggest possible difference, that is, the number at j minus the number at I. If we can't find any pair that fits the rules, we should just return -1. Script. Let's walk through this first example together. The list is 7, 1, 5, 4. We're looking for a smaller number that appears before a larger number. Let's start with 7. Can it be our smaller number? Well, nothing after it is bigger than 7, so that's a no-go. How about the next number 1? Can it be our smaller number? Let's look at what comes after it. We have 5, and hey, 5 is bigger than 1. What's their difference? 5 minus 1 is 4. Okay, so 4 is a possible answer. Let's remember that. What about the number 4, which also comes after 1? 4 is also bigger than 1. The difference is 4 minus 1, which is 3. Is 3 better than our current best of 4? Nope, so we'll stick with 4. We've checked all possibilities, and the biggest difference we found was 4, so that's our answer. Script. Now what about this case? The list is 9, 4, 3, 2. Let's try again. Can 9 be our smaller number? Nope, nothing after it is larger. Can 4 be our smaller number? Nope, the numbers that come after it, 3 and 2, are smaller. Can 3 be our smaller number? Nope, 2 is smaller. We've run out of numbers. We never found a single pair where a number was followed by a larger number. In this situation, the problem says we should return -1. Script. So what's the first idea that comes to mind? Usually, it's brute force. We could write two loops. The outer loop picks our first number, at position I. The inner loop then checks every single number that comes after it, at position j. If we find a pair where the number at j is bigger, we calculate the difference and see if it's the biggest one we've seen. This will definitely find the right answer, but it's not very efficient. If the list is really long, this approach could be too slow. We're looking at something that takes roughly n squared time, where n is the length of the list. We can do better. Script. Let's think about this differently. The goal is to make the result of the subtraction as big as possible. When we're looking at a number, let's say at position j, what would make the difference huge? Well, we'd want to subtract the smallest possible number from it. And that smallest number has to be one we've already seen, somewhere before position j. So what if, as we walk through the list, we just keep track of the minimum value we've encountered so far? The script. This leads to a really elegant one-pass solution. We'll go through the list just once. As we move along, we'll use a variable to remember the smallest number we've seen up to our current position. Let's call it the prefix minimum. Then, at each new number we visit, we'll do one of two things. Script. Here's the complete Python code for this idea. It might look a little dense at first, but don't worry, we're about to break it down piece by piece. The core logic is actually quite simple once you see it in action. Script. First, let's set things up. We need a variable to store our final answer. We'll start it at -1. Because that's what we need to return if we never find a valid pair. Next, we need to track that smallest number so far. We'll call it premin. To begin, we can just assume the very first number in the list is our initial minimum. Script. Now for the heart of the solution. We loop through the list, starting from the second element. For each number we ask, is this current number greater than our premin, the smallest value we've seen so far? If the answer is yes, we've found a valid pair. We calculate the difference. That's the current number minus the premin. Then we check if this new difference is bigger than the best answer we've found so far, and update it if needed. And what if the answer is no? If the current number is not greater than our premin? Well, that means we've just found a new, even smaller number. So we update premin to this new value. This new, smaller premin will help us find even bigger differences later on in the list. Script. So how does our new approach stack up? It's incredibly efficient. For time, we only have to look at each number in the list one time. So the time it takes is directly proportional to the size of the input list. We call that big O of n, or order n time, where n is the number of elements in the list. For space, We're only using a couple of variables to store the answer, and the prefix minimum. The amount of memory we use doesn't change, even if the list has a million numbers. This is called big O of 1 or constant space, and it's fantastic. Script. So to wrap it all up, we started with a problem about finding a maximum difference. The simple brute force way would have been too slow for large inputs. The key insight was to reframe the problem. Instead of looking for all pairs, at each step we just asked, what's the best difference I can make with the current number? The answer always involved using the smallest number we had seen before that point. By keeping track of that running minimum, we created a super efficient, single-pass solution. It's a great example of how a small change in perspective can lead to a much better algorithm. Script. I hope that breakdown made things clearer. If you found this helpful, a like or a subscribe would be amazing. If you have any questions or a different way of thinking about it, drop a comment below. I'd love to hear it. Thanks for your time, keep on coding, and I'll see you in the next one.